don't know. Oh, there it is. Okay, so looking at sine of 43 pi over 12. So the idea is that we want to write this as a sum of two, or difference of two special angles, so that we can then use the formula, and I'm going to try to write it as a sum because that's always easier. So the idea is, to me it's easier, writing it as a sum of two special angles, so that I can use this formula. Okay. But the problem is, what do the special angles look like? Well, they're pi on 6, pi on 4, pi on 3, pi on 2, and then multiples of each of these. So past pi on 2, then we can have 3 pi on 6, 4 pi on 2 pi on 3, and then 3 pi on 4. So that this is moving into quadrant 2 now. And then 5 pi on 6, and then pi, and that's all of the first and second quadrant, so I'll just say etc. So this is, so of course then there's the third and fourth quadrant as well. But we want them in terms of denominators of 12. So I could write this as 2 pi on 12. This one would be 3 pi on 12. So these are still special angles, just written with the denominator of 12. I could write this as 8 pi on 12. This 3 pi on 4 could be 9 pi on 12. 10 pi on 12. 12 pi on 12, etc. Oops. Forgot how to spell etc. Is it ETC or ECT?
Etc. ETC.
Okay. Anyways, so of course these aren't all of them, but these are, this is a good start. So you could look at 43 over 12, or 43 pi over 12, and just try. Basically, the idea is to just try things. And I'm looking at this, and I'm realizing, first of all, that this has a full rotation in it, because a full rotation, whoop, oh my goodness, I'm not thinking straight. Okay, a full rotation is 2 pi, in other words, 24 pi over 12, right? So actually, without even worrying about splitting this first, without even thinking about splitting it as two angles, we can pull out a full rotation. 43 pi over 12, just pull that out and say, what is 43 minus 24? 19 pi over 12. We can write it just like that. Okay. Okay. So we have this is exactly the same angle. I'm not pulling it apart. It's just removing that extra full rotation from 43 pi over 12. Okay. So now I need to think about how to split up 19 pi over 12 using some of these, or possibly ones beyond this. So I'm thinking, oh look, right there, 9 and 10. There we go, 9 and 10. So 9 pi over 12 plus 10 pi over 12. And those are equivalent to these special angles 3 pi on 4 and 5 pi on 6. There we go. These are going to be the special angles we use to get this. So the way this would work is I would say sine of 43 pi over 12 is actually equal to sine of 19 pi over 12, just by removing a full rotation. That's like a separate thing. We've done that before, removing full rotations from angles. Then this is equal to sine of 9 pi over 12 plus 10 pi over 12. Just splitting 19 as 9 plus 10. That is the same as sine of, now write it in terms, simplify these fractions so that you can recognize these special angles. 3 pi on 4 plus 5 pi on 6. Now you're ready to use this formula. So you'll say sine, so this is equal to sine of 3 pi on 4 times cosine of 5 pi on 6 plus cosine of 3 pi on 4 times sine of 5 pi on 6, which is this formula. Usually this is written with these flipped the other way. It doesn't matter though, they're multiplied, so that doesn't really matter. And then from here, since all of these are special angles, all we need to do is look at the unit circle and determine what each of these are, and then the last step will be to multiply, do some algebra. Let's see, sine of 3 pi on 4 is root 2 over 2. Cosine of 5 pi on 6 is, I hope I'm getting these right, negative square root of 3 over 2. Right, let's do tiny triangles. Yeah, and then plus cosine of 3 pi on 4 is negative root 2 over 2. And then sine of 5 pi on 6 is 1 over 2. Yeah, that should be it. And then multiplying everything, I'm going to have negative square root of 6 over 4 coming from this product of these two, plus, negative square root of 2 over 4 coming from the product of these two. And then that's going to be negative square root of 6 minus square root of 2 all over 4. That would be final answer. I feel like I got one of these wrong. I don't know why. Let me see. Cosine of 3 pi on 4. Cosine's negative, yeah. Sine of 5 pi on 6. Yeah, that's fine. So there we go. The other one was cosine. Oh, before I do this one, the way that guy was doing in fact, I think he was working with 19 pi over 12. He was writing 19 pi over 12 as, what did he do? He pulled another rotation out to write it as a negative angle. But it shouldn't have been negative 7 pi over 12. It should have been negative 5 pi over 12. So either I misheard you or the video is wrong, which I hope that's not it, or maybe something different was happening in that video that, I don't know. But the point is that there are many different choices to make here. We could pull a whole nother rotation out, write it as a difference of two angles maybe, and use a different formula. There are just tons of different ways of doing this. I like to always use a sum of two angles because I just think it's easiest. And that's what I did here, wrote it as a sum of two angles. Okay, so cosine of 11 pi over 12. Now this has the same denominator, so I can actually use this list again. I want to write, and there are no full rotations to pull out of this, right? So I don't need to worry about pulling out a full rotation like I did with this previous problem. So I'm going to go ahead and write this as cosine of something plus something. Hopefully I can write it as a sum of two things, because that's the easiest. Let me look at my list here and say if it was 2, no. Oh, here, no. 3 and 4. Let's see, 6. How about these two? 8 and 3. that adds to give 11. So I'll say 3 pi over 12 plus 8 pi over 12.
Yeah, I'm good.
Okay. And now I'm ready to use the formula that says this is the same, or well, actually, before I do that, let me go ahead and re-simplify these so I know exactly what angles I'm working with here. And now I can use the formula for the sum of cosine, the sum of two different angles inside of a cosine, which is going to be cosine of the first times cosine of the second minus sine of the first times sine of the second. Okay. So that's going to be square root of 2 over 2. So now these are all special angles, so I can go ahead and just replace them with, just looking at the unit circle. Let's see, this one will be negative 1/2, I believe. And then minus square root of 2 over 2. That's the sine of pi over 4. And then this one would be square root of 3 over 2. Right, let me see, let me draw my 2 pi on 3 angle. Yeah, 1 square root of 3, 2, it's negative. Yep, okay, so this is equal to negative square root of 2 over 4 minus square root of 6 over 4, which is equal to negative square root of 2 minus square root of 6 all over 4. There we go. So the thing that is most helpful is if you're dealing with some unknown angle here with some denominator, write your special angles in terms of that denominator. That's why these are all in terms of 12. Just makes it easier to pick them out. So if the denominator was of 15, then you'd want to rewrite all of these angles with a denominator of 15, if possible. 15 would be a weird one, but if it was like 24 or something like that, then you'd want to write all of these in terms of a denominator of 24. That way you can easily pick the ones that add to give whatever it is you're looking for. And also watch out for full rotations. If you can pull a full rotation out like this one, makes the problem much easier.